hang in there with me. It's almost over. I'm the last one. Don't worry about it. So yeah, I'm Diana Freitas, and I'm working with Dr. Benham, and we're studying Andopleura elegantissima, and not like Almeida. She's more looking at the symbiotic relationship, and I'm more looking at the host and how the fact that it's symbiotic affects the general living of the anemone. So the big deal right now is climate change, right? Everything's changing, and everyone's interested in this, and it's a big deal in ocean waters. It's a big deal for example, in tropical waters with coral reefs. There has been numerous sightings of coral bleaching because of the rising in temperature, and these animals are symbiotic. The coral bleaching is that they actually lose their symbionts because of the thermal stress. Actually, this is zooxanthellae, the microorganisms that live with the coral, and these aren't the only cnidarians that have a symbiotic relationship. Like Almeida already told us, we have right here in temperate regions, we have the intertidal anemone, Andopleura elegantissima, which has not only zooxanthellae but Solchlorelli too. Has two types of symbionts, and well, it has been shown by different works that have been done up to this time that when it is exposed to thermal stress with high temperatures, they tend to expel their symbionts, just like corals do in tropical regions. And so this is what happens. This is a normal symbiotic anemone, and that's what we call an APOS, an aposymbiotic anemone. That's when they expel their symbionts. The fact is that this is an intertidal anemone, right? And so when the tide goes down, I mean, like, these are tides in, like, regular, right? So an anemone that's in, like, very close to the low tide, to the water level in the low tide, might maybe have an exposure of 2 hours, while an anemone in the highest part would probably have an exposure of up to 15 hours without, I mean, it'll be humid, but it's exposed to air, to high temperatures and direct sunlight. So if they are, as we've seen, they're affected by high temperatures, then how can they live in these intertidal regions where they're so exposed? So, like, what we've been thinking is that maybe they have some kind of way to keep their temperature, at least to some extent, at a level that they're okay with. So, like, my question is, can Andopleura elegantissima thermoregulate? Like, can they do that? And I mean, it would be very important if they did. It would explain a lot of things. And so I'm working with Dr. Benham. That's what we call in Spanish con las manos en la masa. Do you know what that means?
Yeah.
Yeah, that means like infragante. Yeah. So our first gathering, I went with Almeida too. It was up in Cattle Point in the San Juan Island, and so this is our study site, and we actually collected anemones from this part right here, and these are the anemones in an intertidal when we went into low tide. So you can see them; they're exposed. They're right there. The wind can hit them. It's direct sunlight to them. So. The anemones. So what I'm doing is I have this thing called a wind tunnel, and this thing called a wind tunnel has actually a fan in this part right here, and I put heaters on the back of that fan, so it's going to be pumping warm air into there, and the air is going to pass through and over to this side where the anemones will be in a tray, and we'll still working out the kinks on that, but the general idea is that I'll be kind of simulating a low tide process, and I will have them completely submerged at first, and then I will be slowly exposing them to the warm air that's going to be coming through the wind tunnel. And I'm going to have the control, which will be measured by the loggers that we right now have in the study site, and that's going to be measuring temperature. That's going to be right beside where the anemones are, so they'll be exposed to the same things. And I'm going to be measuring the inside temperature of the anemones. So what I'm going to be doing is I'm going to be tracking these temperatures throughout the experiment, and I'm going to see if there are any differences between the logger, between the temperature, the inside temperature of the anemones, and I'm going to be kind of alternating some things that could be affecting, if they can thermoregulate, that could be affecting that ability. And one of them would be size, the size of the anemone. I would be using we just worked on it today, image analysis, to measure these animals. We're probably going to be comparing between symbiont and apose to see if there's any difference, and between single anemones and in packs, and anemones that are in the outsides of the pack and the insides of the pack. So we're going to be doing all kinds of comparing, and hopefully that would give us an insight on the processes that happen inside a cnidarian, and maybe that would give us a better idea of what's going on with them. All these changes are occurring in the environment, and what are they doing to cope with that? Maybe these anemones are probably more used to temperature changes than maybe corals, but that could give us an idea of what they're capable of, at least. And so yeah. I hope you all do too. And that's it.